Okay, we're doing more notes on conditional probability today. And I think these notes that we're using in our geometry classes are making this a little bit more complicated than it needs to be. So we're gonna still we're not gonna use this formula. We're going to use what we sort of talked about the other day, that if we have the probability of B given A, then we just take our number of A's and then put the number of B's sort of within that A over it. And so we're just going to make this fraction. We're going to not do number 1. That's out. And I want to get to number 2. So 2 is still conditional probability. This last part's going to be our conditional probability for these questions. The first 2 parts, well, let's read the question, I guess. A box contains 6 red tags numbered 1 through 6 and 4 blue tags numbered 1 through 4. A tag is drawn at random. Using the formula, find these things. All right, we're not going to use the formula, but let's sort of think about what this is saying. So we have 6 red tags. And let's see, I got a color here. So our red tags consist of 1, 2, 3, 4, 5, and 6. And we got blue tags. Look at these colors. 1, 2, 3, 4. If we have, all these tags in the box and we're drawing one of these tags at random, what is the probability of, here, let's do an easy one first. Let's do the red. What is the probability of choosing a red tag? So how many tags total do we have? Well, we have 6 red tags. We have 4 blue tags. So it's going to be out of 10. And what is the probability that we choose a red tag? Well, 6 of our tags are red. So we have a 6 out of 10 chance of choosing a red tag. What is the probability of choosing an even tag and a red tag? So basically, what is the chance that the tag is both even and red? So if we're looking at all of our options here, it looks like, we have 6 red tags, and of those 6, 2, 4, and 6 are even numbers. So it's still out of 10, okay? There's still 10 tags in the box, and if you pull a tag at random, what is the chance that this tag is both even and red? Well, there are 3 sort of numbers, or there are 3 tags in the box that are even and red, 2, 4, and 6, and the red tag. So now this last part. This is using what we talked about Monday and Tuesday. What is the probability of choosing an even tag given that the tag is red? So we're not going to put it over 10 this time because we're not, talking about the whole box. We're saying if we chose a red tag, what is the chance? What are the chances that it was an even number? So how many red tags did we have? We had 6 red tags. And how many of those red tags are even? There are 3 red tags that are even. We're not going to look at the even numbers from the blue tags because we're saying given that we picked a tag that is red, what is the chance that that red tag is even? And so we don't want to include the blue evens because that's not red. Okay, so part B kind of asks the same thing. What is the probability that we choose a tag that is both red and even? They put it in a different order here, but it doesn't matter. This is still asking the same thing that this first part was asking us. What is the probability that we choose a tag that is both red and even? There are 3 tags that are both red and even, and so we have a 3 out of 10 chance of choosing that. What is the probability of choosing an even tag? Okay, this is going to be different from this one up here. I mean, these say 2 different things, so I guess that makes sense. How many even numbers do we have in the box? Well, we have 3 even numbers that are red, and we have 2 even numbers that are blue. So we have 5 total even numbers out of the 10. Okay, so what is the probability that we choose a red tag given that that tag is an even number? Okay, how many even numbers do we have? We had 5 even numbers. We sort of wrote it right here. You can look over here as well. 2, 4, and 6 from the red, 2 and 4 from the blue. There are 5 even numbers. How many of those even numbers are red? 3 of those even numbers are red. So I think what these first 2 examples are sort of trying to show you is that, order kind of matters. Finding the probability that we choose a tag that is even given that it's red gives you a different probability than if we choose a red tag given that it's even. So just pay close attention to sort of what you're doing. Order matters. All right, so C, what is the probability of less than 4 and odd? Okay, so what is the probability that we choose a tag that is less than 4 and also odd? All right, so we still have 10 tags total still. There are 10 tags sort of in this box. And what is the probability that we choose a number that is less than 4 and also odd? So both of these have numbers less than 4. 1, 2, 3, 1, 2, 3. And 1 and 3 in both of these red and blue tags are both odd numbers that are less than 4. So we have 4 tags total. This one, this one, this one, and this one that are less than 4 and odd numbers. What is the probability of choosing an odd number from the box? So if we add up all our odd numbers, 1, 3, 5, 1, 3, we have 5 odd numbers out of the 10. Okay, and now for the conditional probability part. What is the probability that we choose a number that is less than 4 given that that number is odd? Okay, so how many odd numbers did we have? We kind of wrote it right here. We had a 5 out of 10 chance of choosing an odd number. So there are 5 odd numbers sort of in the box. You can also count it up again if you want. And what is the probability that we choose an odd number that is less than 4? So we kind of just wrote that right here. But we have a 4 out of 5 chance because there are 4 odd numbers, 1, 3, and then this 1, 3, that are less than 4. And the only one that's not less than 4 is this 5 right here. So we had a 4 out of 5 chance of choosing a number that's less than 4 given that we choose a number that is odd. Ooh, that is confusing. All right, let's get to number 3. So I don't think these are as confusing because they don't have those sort of lead-up questions. You're just sort of doing conditional probability. It says, in its monthly report, the local animal shelter states that it currently has 24 dogs and 18 cats available for adoption. 8 of the dogs and 6 of the cats are male. Okay, that seems important. Find each of the following conditional probabilities if an animal is selected at random. So what is the probability that the pet is male given that it's a cat? Okay, so I'm going to write this out in that probability sort of form, kind of like this right here that we were working with on Monday and Tuesday. So what is the probability that we choose a male given that the animal we choose is a cat? So how many cats are there? There are 18 cats total available. And how many of those cats are male? 6 cats are male. Okay. And then B. What is the probability that the pet is a cat given that it is a female? So find the probability that we choose a cat given that we choose a female. I think this is going to be really tough here. And I don't know if they want us to make a table or what. I think they do want us to make a table. Ugh, I really don't want to do that. All right, let's think about this here. We have... All right, how many total animals did we have? We had total animals 24 dogs plus 18 cats. That's going to give you 42 total animals. How many of those animals were male? 8 plus 6, so we had 14 animals that were male. Now I'll write off to the side here, that was 8 plus 6. So how many females must we have in this sort of shelter? Well, if we have 42 animals total and 14 are male, just subtract 14 from 42 to find how many females we have. So 42 minus 14 is going to be 28. So we have 28 female cats and dogs. All right, so now we can do this question. All right, find the probability that the pet is a cat given that it's a female. All right, we had 28 females. And how many of those females were cats? Oh man, we got to do more with this. Oh, this is so annoying. All right, well, if let's just think about this logically here. If 6 of our cats are male and we only have 18 cats total, then this is getting really gross. then 18 minus 6, we should have 12 cats that are female. So we should have a 12 out of 28 chance. So let me say that again. We have 18 cats total. 6 of those cats are male. So if we're finding the probability that we choose a cat given that it's a female, we had to first figure out how many females there were. There were 28 females. And then what is the probability, how many cats are female? Well, it didn't tell us that in the question. We had to figure that out. And the way we figured it out was if 6 of our cats are male and we have 18 cats total, we just said 18 minus 6, there must be 12 cats that are female. All right, flip over. We got this Venn diagram here, shows the intersection of two sets A and B. We don't know anything about A and B. So this is sort of review, that there is some conditional probability in here. All right, find the probability of choosing A. All right, so remember, first off, we want to find a total amount sort of in this Venn diagram. So we would add 20 plus 15 plus 45 plus 10 together. If you do that, you're going to get something like 90. I'll write that off to the side. That's 20 plus 15 plus 45 plus 10. And what is the probability, if there's 90 things total, what is the probability that you choose something in circle A? Don't just say 20 over 90. There are 20 plus 15, but this 15 is both in A and B. So there are 35 possible things in A. So you have a 35 out of 90 chance of choosing something in A. Find the probability of B prime. All right, so don't remember this prime means complement, and basically you're finding everything that's not in B. So again, there are 90 things total here. And how many things are not in B? Well, 45 and 15, these numbers are both in circle B. 20 and 10 are not in B, so there is a 30, and I'm just adding 20 and 10 together. There is a 20 plus 10 over 90 chance of something not being in B. All right, so now find the probability of picking something in A given that it's also in B. Okay, so how many things are in B? If I'm looking at B right here, 15 plus 45, there are 60 things total in B. So how many of those things in B are also in A? Well, just this little sort of middle sliver part is in A. So there are 15 things in B that are also in A. And that's our answer. So on D, you're sort of doing the opposite way. Find the probability of choosing something that's in B given that you chose something that's in A. So how many things are in A? 20 plus 15, there are 35 things in A. And what is the probability of choosing something that's in B given that you chose something in A? Well, again, this little middle slither part, or sliver, whatever, there are 15 things that are sort of in B that are in A, so we have a 15 out of 35 chance of choosing something in B given that it was in A. All right, and then these last two questions I don't really like, so we're not going to do them. I know this stuff is tough. Please, please, please look at the video again if you need to. Make sure you do the work that goes with this to sort of practice it, and I'll put a video up for the work as well. Please make sure you go on and do your digital evidence of learning quiz before you finish. Have a good day.